Okay, kids, in this video, we're going to talk about pyramids. Now, the definition of pyramid that we're going to go with is we are going to have a regular polygon base with isosceles triangle lateral faces. Now, as you can see over here, this has a regular polygon base, so this would be a square base. And since I have a square base, I would have 4 isosceles triangle faces, lateral faces. And I can see that right here that I have 4 of these triangles. Now on this one over here, I can see that I have a hexagon base and I would have 6 isosceles triangle faces, lateral faces if you will, and I can see that all right here that this would be the isosceles triangle. Now, since it's a pyramid, all of the triangles are going to meet at a point. Okay, so I can see all of these triangles meeting at a point. And the important thing to note is if I have a regular base, that the isosceles triangle lateral faces are all going to be congruent. So I have 4 congruent triangles on this pyramid, and I have 6 congruent triangles on this pyramid. So by definition, we are looking at a pyramid that has a base with isosceles triangle lateral faces. Now we're dealing with pyramids that have a regular base, and the isosceles triangles for the faces are all going to be congruent. So that's just the basics of what a pyramid is, understanding a few things, that this right here is still called an edge, and that this right here is still called the vertex. But we do have some other terminology now as far as where the triangles intersect with those lateral faces. So that's the basics of a pyramid. Now let's move into this example of finding the surface area of the pyramid. Now we said we're dealing with regular polygon-based pyramids. So if I think of this, I have a square base, and then I want to add in the 4 congruent isosceles triangles when I'm figuring out the area. So if I'm thinking about the square base, that's not too bad. I can see that the square base right here, the dimensions are 10 by 10. So I get 10 times 10, which is going to give me 100. Now what I want to add to that are the 4 congruent triangles. So remember, I need 4 times 1/2 times base times height in order to give me the area of the triangle. So this is what I want to pay attention to. Now this isosceles triangle here, the base is 10, but then this distance right here is going to be 13. So what I need to figure out is I need to figure out the height of the triangle since I already have the base. So let's draw in the height. So I'm going to draw in the height in blue. So this height right here is what I want to find in order to find the area of this triangle. Well, this height, if I draw it in on the pyramid, is going to be that distance right there. And the term for that height drawn in is called the slant height. And the slant height basically is the height of the triangle. So it's the slanted portion of the pyramid right here, which refers to this height of the triangle. Well, if I want to go through this, going through the basics of isosceles triangles and Pythagorean theorem, I get 5 squared plus h squared is going to equal 13 squared. So 25 plus h squared equals 169. I get 144. So h, the height, is going to be 12. So right now, I have the 100 from the base plus 4 triangles. And the area of those triangles are 1/2 times the base of the triangle, which is 10, which is also right here, which is 10, and the height, which we calculated to be 12. So that's 100 plus, that'll be 4 times 60. So that's 100 plus 240. So that's 340 units squared for the surface area of this pyramid. So it's just remembering, in this example, I had a square base, and then I had 4 congruent isosceles triangles. Now let's head into finding all we can about a cone and eventually its surface area. So a cone is very similar to a pyramid in which it has a base, and then the sides, the lateral faces, meet at a point. Okay, but the only thing that's different is that there are no triangles anywhere on a cone. So a cone has a circle base, and then it actually has a partial circle lateral face. Now what I mean by this is if I were to take a circle, so let's take a circle right there, and if I were to go through and cut out the radius and then take these 2 parts of the circle and kind of fold them over, not fold them, but slide them over each other, what eventually would happen when I do that is I would get this cone part. So actually a cone is only made of circles, a circle base and a partial circle lateral face. So if I were to head into the surface area of a cone, let's talk about the base. The surface area is going to be the base, which is a circle, so it's pi r squared. And then I got to add in this part, which is going to be pi times r times s. Now remember, from a pyramid, s refers to the slant height. So that would be s right here, which refers to the slant height of the cone. So I need 2 measurements. I need the radius of the cone, and I also need the slant height of the cone, and that will be what I used to calculate the surface area. So in this example, let's find the area of this cone. Now remember, the cone is broken up into a couple parts. I have this base, which is going to be the pi r squared part of the equation, and then I have this part of the cone right here that goes all the way around, and that's going to be the pi rs part of the equation. So all I got to do is plug these numbers in, the radius, which is 7, and the slant height, which is 15. So if I plug these in, I get this. Surface area is going to equal pi times 7 squared plus pi times 7 times 15. This is going to give me a 49 pi plus 105 pi is going to give me the answer of 154 pi units squared. This is what we call the exact answer, and it is in terms of pi. If I were to plug this into the calculator, I would get 483.8 units squared, which we call the approximate answer, because I'm using pi as the pi button on the calculator, or 3.14, the decimal approximation. Now we're going to head into the idea behind. Now we're going to head into the last shape for this video, which is a sphere. Now a sphere, just like a circle, is the set of all points equidistant from a center point The only difference is that we have a 3D object. So if here is my center point, that equidistance is going to be the radius, and no matter how I draw it in, even though it looks slightly different, this is going to be the set of all points equidistant from that center point. So what we need to think about now is, what is the surface area? Surface area is going to equal 4 pi r squared. So I only need one measurement in order to find the surface area. I need to know what the radius is. And basically, the surface area of a sphere is equal to 4 circles with the same radius. And so if I were to do an example in which the radius is going to be 6, my surface area would equal 4 times pi times 6 squared. Now that as an exact answer would be 144 pi units squared, which as a decimal approximation would be 452.4 units squared. So remember, I have one measurement that makes a sphere. I could get an exact answer for the surface area, or I could get a decimal approximation.